Hi everyone, thank you for joining us today. My name is Kevin Weiner and I will be the moderator on this webinar. I'm excited to be joined by Zach Norman, a solutions engineer at Harris Corporation. During the presentation today, Zach will discuss how you can get the most out of your UAV and aerial data. Zach will also talk about pre-processing UAV data with the ENVI Toolkit. If you have questions at any point during the webinar, feel free to use the question area of your GoToWebinar dashboard. Zach will try to address as many questions as he can, and if he doesn't get to your question, he will follow up with you. And now I'm going to turn things over to Zach.
Thanks, Kevin. Real quick, just to double check, if you guys can hear me, you want to put something in the little questions box so you can hear us? Okay, I think we're being heard. So I'm going to go ahead and get started then. So like Kevin said, I'm going to be talking to you about how you can get the most out of your UAV and aerial data. This is me. My name is Zach Norman. I'm a solutions engineer here at Harris Corporation. There's my contact information. We're going to do our best to address all the questions during the webinar. We're going to have a couple breaks for questions. And we'll also make sure to try to get back to you afterwards if we don't get your question answered. So here's a little bit about what we're going to be talking about today. We're just going to kind of have an overview of Harris Corporation and Harris Geospatial. We've had a lot of name changes throughout the years, so just to make sure everybody's on the same page. Then we're going to talk about ENVI OneButton a little bit and go through a little demo for setting up a project. Then we're going to take a break for questions. Then we're going to talk about pre-processing some UAV data, and then we'll have another break for questions. I do just also want to make sure to point out that this webinar will be recorded and put on the website. So, and then if you guys are interested in getting these PowerPoint presentations, you can send me an email and I will send those to you. All right. So to tell you a little bit about Harris Corporation, it's a worldwide company with about $8 billion total revenue. There's 22,000 employees, 9,000 engineers and scientists. And for Harris, there's kind of 4 overall business segments. We belong to the business segment Space and Intelligence Systems. Specifically, we're geospatial. So there's a little red box on this slide down towards the bottom. That's kind of where we fit in. We're more on the analytics side of things, whereas the rest of this business segment does a lot of sensors. So kind of talk a little bit about what we do apart from ENVI OneButton is, we've got some other software products out there. First is IDL. That was the first product that we had and developed, the interactive data language. It's programming language. It's really easy to use. Then came ENVI, which is the environment for visualizing images. And I'm going to talk a little bit more about that in just a minute. We also have a software solution called Jaguar, which is basically an engine for ingesting data, cataloging it, ingesting live video feeds, and displaying those to different places. And one of the most recent additions to our catalog is ENVI Geiger mode LiDAR. It's basically a new LiDAR sensor that collects really high resolution data so that you can get higher quality data, higher density at a cheaper price. So to talk a little bit more about ENVI and the things you can do with ENVI, there's a lot of different data types that we support. Those go for multispectral, hyperspectral. We also support LiDAR, elevation products. We've got a module for supporting SAR as well. And with those different data types, there's a lot of different analytics that can be performed on them. This is just a short list. It's by no means inclusive of all the different tasks and workflows that we have. But we do lots of image classification, feature extraction, change detection. We also work well with multispectral and hyperspectral data for doing species identification and things like that. But that's enough with ENVI. We're going to talk about ENVI OneButton now. So if you're unfamiliar with ENVI OneButton, it's actually a software solution. Sorry, I'm waiting for the slide to catch up. Okay, so ENVI OneButton is a software solution developed from a business partnership between Icarus and Harris Corporation. It's basically an industry-leading software package that's designed to generate georeferenced, orthorectified mosaics of your UAV or aerial data. It works with any frame-based sensor as long as you have a focal length and a sensor pixel size. OneButton can process your data. And kind of more important than that is getting into the why when you actually need some sort of image stitching software. When you collect your data, there's a couple different challenges. First off, you have your viewing angle and your sensor orientation. This and the accuracy of your GPS information, your GPS information could be off anywhere from 1 to 10 meters, and so that makes it really hard to try to figure out where your picture that you take should actually be located. And so image stitching software works to create some sort of a model, be that a bundle block adjustment or a different algorithm, to try to solve this problem and figure out where your images are at. So to kind of give you an idea of what this looks like, here I've got on the left, I have raw data. This was 340 different images. I loaded them all into ENVI, and it took quite a little while. And on the right is the orthomosaic from ENVI OneButton. Now, the images on the left, you can't really do much with them. They're not where they should be. It's just where the GPS says they are. They're not oriented for sensor orientation. And so it's just, you can't work with it. And that's kind of a big motivating factor on why you need to use ENVI OneButton. So before we get into the demo, there's a couple things I want to talk about. The first is actually that we've got an exciting promotion going on with ENVI OneButton. For now, until October 31st this year, you can get OneButton for free. It's a free trial. You can download it. No questions asked. So sometimes it's easiest to let the software speak for itself. So if you've got lots of questions, if you're curious if it'll work with your data, you can actually get ENVI OneButton, download it and install it, and try it out with your data to see how it works. In addition to that, there's actually, within the first 60 days of downloading, if you decide that you want to purchase, you can get a 25% discount on ENVI OneButton and ENVI OneButton Professional. And the last thing that I want to bring up before we jump into the demo, there's going to be another webinar on May 25th. It's really going to focus on the analytics and the post-processing side of things after you get your orthomosaics from image stitching software. It's going to be pretty cool. We're going to talk about some applications that can apply to different industries, but it's going to have an emphasis on precision agriculture. So that's all I had for the intro. We'll go ahead and we'll set up a project for ENVI OneButton. I do want to point out that if you want to follow along at home or try this out yourself after you've downloaded ENVI OneButton, everyone has the sample data that I'm going to be using. So if you want to find it, if you open up Windows Explorer, type %appdata, and you hit enter, there will be a folder called sample data. And if you open up this folder, within there's going to be a bunch of JPEG files. And so these are what I'm using. I just copied them to a directory on my desktop. So I'm going to go ahead and open up OneButton now. We'll give this just a minute to pop up. All right. So this is the interface. There's not much that you can do until you've actually created a project. So we're going to go ahead and do that. To do that, I click on the New Project button in the top left corner. And this is the dialog. There's only a couple things that we need to set. First is we're going to choose where we want our project file to be saved at. So I'm going to click on the ellipses for a dialog to appear. I'm going to navigate to the folder on my desktop called Sample Data where I save the images. And this is where I'm going to make my project. I like to put my projects in the same place that my images are stored. This just helps me stay more organized. Then I don't have to worry about all fancy project names or anything like that. But you can put them wherever you want to. Next, we need to pick the image folders. Since my project file is in the same place as my data, I just navigate to the same directory and hit OK. At this point, a little dialog will pop up and it'll say it's gathering sensor information and metadata from the images. I do just want to point out a couple of things here. So for this third option for the data source, you can either search for your GPS information in the EXIF metadata for the images, or you can choose a GPS file. And the GPS file is basically just a text file with the name, the latitude, longitude, altitude, and that's minimally what you need. If you have the sensor orientation, such as the roll, pitch, and yaw, you can include that as well. The same applies for sensor information. Over here where it says calibration file, if you don't have any metadata in your images so that OneButton can determine the sensor pixel size and the lens focal length, you can also create a text file called a CAM file to store this information. So there's only two things I want to mention before we actually create this project. I'm going to change my project type from agriculture to mining. And then I just want to mention that when you actually change your project type, there's certain parameters behind the scenes that are going to be changed during the bundle block adjustment when the orthomosaic is actually generated. And if you choose a project type that suits the data set that you've captured, then it can help improve the accuracy a lot. The last thing to mention is this box for allow pixel value modification. If you want to make a pretty picture, then you can turn this on. There's things like color balancing, feathering, accounting for brightness differences. And so if you're just looking for a RGB orthomosaic, which is what this data set is, then you can leave that on. Otherwise, if you're using hyperspectral data, I would recommend that you turn that off so that you preserve your pixel integrity. All right, so this is all we had to do to set up the project. Apart from all of the explaining, it only takes maybe 30 seconds or a minute to set up your project. It's super easy to use. So I'm just going to hit OK. And then a little box is going to pop up saying calculating kappa values. That's basically how the images are rotated as they would be on like the surface of the Earth. And so OneButton runs that process automatically in the background so you don't have to worry about it. So after I hit OK, the processing output dialog will appear. I'm going to hit close on this. We'll come back to this later. So here, the interface actually shows some useful information now. You've got little red dots wherever your images are located. You can also change your base map. So I'm going to zoom out here, and we'll change to world imagery. And give that a second to buffer. And you can also set your background to be OpenStreetMap. So the cool thing about OpenStreetMap is it kind of has some symbols for what's going on in the area you're looking at. And you can kind of see there's little mine symbols. So choosing our project type as mining is probably a good idea. The other cool thing about this map is you can see where your images are located with respect to the globe. So I can zoom out all the way. I think these are in Goa in India. We'll give that a second to buffer so we can actually see where we're at. So it's pretty cool. Just wanted to point that out. So there's a couple things I do want to point out as well that you can use in the interface. Let me zoom back in here. So up in the top left corner, there's a button called Add/Edit Ground Control Points. So if you have GCPs, your ground control points, then you can load them here through this dialog. All that you have to do is you just have to, OneButton will automatically find the images that could potentially have your ground control points in them, and then you just have to click on the images to specify that this feature or this marking actually corresponds to that GCP. Another cool thing to point out is this image view/edit. So I'm going to click on this button and it's actually going to open up. So this dialog, we'll let this load. It's going to show every one of the images, and I can go around, I can click on different ones. It's got the world imagery for the base map, which is really useful in this case because then you can actually see how your images are kind of oriented in this right side, and then you can see, oh, with that base map, this actually should be about here. In this dialog, you can also do things like change the camera orientation. The camera orientation is basically how the camera is set up on the UAV as it's flying. I'm going to change the camera orientation back to 1 because that's what it should be for this project. Other things you can do, in this dialog you can remove images from the database, so you can take them out completely, or you can manually rotate images, and that's just in case if the orientation is really off, then you can change the camera orientation and then you can rotate the image to be where it really should. But for the most part, it's a really good automated process and you don't need to do anything manually, but it's there in case you want to. All right, so our project's pretty much set up now. All we got to do is specify the output options. So I'm going to click on Output Options up in the top bar, and it's going to bring up the Processing Output dialog. I want to point out that there are 6 different things that we can get out of ENVI OneButton. You can get GeoTIFF image maps, which those are basically your orthomosaics. You can generate a rapid image map. This is an orthomosaic that is generated very quickly. So say if you're out in the field and you just want to check and see if your data is, if you have the coverage you thought you did, then that's a good project for that. The next 2 items we have are dense GeoTIFF terrains in 3D sparse point clouds. And the last 2 items are 3D dense point clouds and Esri mosaic data sets. There's more information about all of these products in the ENVI OneButton user manual. Each of them kind of have some considerations for data collection for increasing the quality with the outputs. But I already ran this project ahead of time. It takes about 5 minutes to run, so we're going to skip ahead to the results. So I'm just going to hit close here. One really cool thing about OneButton is that when it's done processing, it generates a report for you. So I'm going to navigate to that and open it up. Okay. So this processing report contains some basic information about your project. It'll give you like the project name, the project type, area, ground sampling distance. You'll also see processing results. So if I scroll down a little bit, it'll give you the total processing time. I highlighted that in blue. And then you can also see some chips of just the final orthomosaic and terrain model, just some approximate solutions, and so it's really easy to share these with people. Then we also take a look at the image initial and calculated locations. So kind of like when I was describing how this problem is really challenging, trying to determine how, where the sensor actually was when the picture was taken. This is a good place where you can kind of check and see, the accuracy of your GPS information. Another really useful addition to the report is the coverage map. This is a quick thing you can glance at to try to see how many images are covered in a certain area. And lastly, there's a connection map. This connection map is really cool. It's a visual way to see how many tie points were found between images. So basically, the thicker the lines between the blue squares, then the more tie points are found or connections. And this is a great way that you can kind of quickly and visually see, if you have a region where there's no connections, then your orthomosaic isn't probably going to look very good in certain regions. And then you can kind of adjust your flight plans for the future, make sure you have more overlap on your images, and make the appropriate corrections. So while these reports are really useful, I think it's even more helpful to actually look at the orthomosaic itself, because after all, that's what we're here for. So I already have that, the result from ahead of time, just like the report. So here in my folder, I've got, it's autotile_1.tiff. This is an output directly from OneButton, no smoke and mirrors. And I'm just going to demonstrate that we can ingest their files by default. So if I just click and drag this file into the ENVI display. Then I'll see that it pops up. I can zoom out, I can pan around. You'll actually see the image. You know, if I look closely, I don't see any seam lines. I don't see any places where the orthomosaic was generated poorly. There's a few artifacts around the edges, but that's kind of expected. So overall, it's a very high quality mosaic. And to also point out real quick, in the bottom of the ENVI workbench, in the lower left corner, you should see latitude, longitude, and then in the middle, you'll see projection. So that's just to demonstrate that these are geo-referenced. You know, you actually have projection information within these images, and it's not just some TIFF file that's being opened up. So at this point, I know that was a lot of information, pretty quick. That's all I had to show for ENVI OneButton, so we'll go ahead and open up the floor to questions.
Great, Zach, thank you. So as a reminder, feel free to type in any questions that you have for Zach in the question area of your dashboard. Let's see, the first bunch of questions, Zach, relate to the trial of ENVI OneButton. Can you reiterate again the length of the trial?
So that goes until October 31st, 2016, this year. So you can use OneButton for 6 months almost, you know, for free of charge. So if you're interested in actually seeing if it will work with your data, I mean, you can just download it and try and see if it will work.
Great. The next question is, what happens if I don't have metadata with my images?
So you need to have some sort of metadata. If it's not in your images, then you can have a GPS file, which is just a text file with that information, and I'll show an example of that in a few minutes. But either way, you have to have some information about where your images are located.
All right. Next, which data set do you use for the satellite base map, and what is its spatial resolution?
The satellite base map, that's from Esri. I'm going to see if Asaf knows more about that. Can you chime in, Asaf?
Yeah, hey Zach. Yeah, that's from Esri. That's satellite data. I'm not sure what the resolution is, but you know, you can get an answer for that in a couple of days. It's important.
Thank you, Asaf. Asaf, you're with Icaros, so maybe this question actually might be for you as well. Do you questions about the types of data that are supported? So someone asked about Trimble UX5 data, another about GoPro. Can you answer that one, please?
We support any frame-based sensor, and GoPro, I think if you're a professional user, you'll be using it without the fisheye lens, and no problem. We don't have any restrictions on sensors as long as they're frame-based.
And then I think, Zach, this one might be for you. Are all the capabilities that you showed exposed via command line interface or API?
There's no API yet. This is something, Asaf can correct me if I'm wrong, it's kind of in the future. I think there might be some plans to get some sort of an API or a way to call this programmatically in place, but there's nothing right now.
This is Asaf. I just want to add that we do have an SDK, and you know, we can discuss it separately with anyone interested in it.
Great, thank you. How do you assign GCPs to a specific image?
So I don't have ground control points for this image, but when you open up, I'll just open it up here. So you guys should see this in just a second. So in the top left, there's ground control points. All your GCPs will be listed here, and then below the images that are close to that GCP will also be shown. So you can click through on your images, and then when you find your GCP, you can click on this little crosshair, and then click in the image where that GCP is located. So that's how you tag them in your images so that OneButton knows where they are.
All right, let's see, next question. What raster data formats can ENVI OneButton import?
So data formats, correct me if I'm wrong, Asaf, it's JPEGs and TIFFs. Are there any others apart from that?
Yeah, JPEG and TIFF, and you can talk about multi-channel and multi-page.
All right. Does OneButton take advantage of a PC's GPU to speed processing?
Yes. So OneButton will use, it's multi-threaded, so if you have 8 cores on your machine, it will use all 8 cores, and it also is GPU enabled.
Next one, how accurate are measurements of the example you created given that there's no GCP used?
I'll let Asaf answer that one.
Okay, so the accuracy is closely related to the GPS data. If you have GCPs, obviously you'll be more accurate, but in most projects we can get down to, we talk for accuracy in terms of pixels and not actual centimeters or meters, because it depends on the resolution you're applying. But back to the point, we generally can generate accuracies of around under 10 pixels for each project. So, if you're shooting at 1 centimeter resolution, that'll be 10 centimeter accuracy in general.
All right. We've had a couple questions about comparing ENVI OneButton to software like Fix.
You cut out there a little bit, Kevin.
Oh, I'm sorry. We've had a couple questions about using ENVI or comparing ENVI One software like PixE.
You cut out there again, but the question was, I think, how does ENVI OneButton compare to other image stitching software like PhotoScan or Pix4D?
Yes, correct. Sorry if I didn't hear me.
No worries. I'll let Asaf answer that one.
Okay, well, first of all, Pix4D and as you saw, many Pix4D came from a more close-range domain, so they may be good with handling smaller areas. Once you start to scale up and reach tens of thousands of images, we do a better job there, first of all. Second, we have we're much faster in processing. We've done some benchmarking, and we found most cases we are 50% faster. We also use semi-global block matching as a standard, and that gives you much more accurate results in your mosaics and models. We can very easily ingest multi-page TIFF, and for multispectral imagery, that is very important. We can also, with our OneButton Professional, use thermal and RGB, which is something I believe Pix4D does not have. And we also integrate with Harris and with Esri very seamlessly. You just saw the output for the Mosaic data set and how we needed to ingest it into ENVI and also run it. We have plans of integrating it much more closely in the near future.
Thank you, Asaf. Zach, I think this one is for you. Do you need ENVI in order to run ENVI OneButton?
No, you do not. So they're standalone software packages. You don't need ENVI or IDL in order to use OneButton at all. I will say if you do want to use OneButton Professional, you will need to have an ARC license. And I think that that's something that they're trying to get away from in the future. Is that right, Asaf?
Yes, we are planning to move away, but there's no clear timeline yet, but it's going to be sooner than later.
Okay. Well,
great. Does ENVI OneButton support imagery acquired via line scan imagers?
No, we do not at this time.
All right, let's see. I'm just filtering through. There's a lot of really good questions. And again, they'll try to address as many questions as they can. And Zach, did you want to jump to part 2 or of the webinar? Okay.
Probably keep things moving. So Yeah, we're going to go ahead and start with the second portion of the webinar. We're going to have a big list of these questions. We'll make sure to get back to you if you don't have your questions answered. You also have my email, so then you can bug me in case we forget. So, okay. Give me just 1 second here. Okay, so the second half of this webinar is going to be talking about pre-processing your UAV data with the UAV Toolkit. So in case you missed it earlier, here's my contact information again, or if you joined us late. So yeah, there's my email, and we'll go ahead and get started then. So what is the UAV Toolkit? The UAV Toolkit is a complementary, customer-driven, it's also an IDL-based solution that kind of tries to bridge the gap between ENVI and IDL and image stitching software to pre-process data that needs to be pre-processed. And I'll show you what that looks like in just a second. So even though we're really focusing on ENVI OneButton here, we'd really like to play a part in your processing chain no matter what image stitching software you use. So to kind of give you a look at what this is and kind of what sort of sensors might need to be pre-processed, some sensors have band alignment issues. So if it's a sensor that has multiple lenses, then the lenses might not line up perfectly with each other. And so then you can see something that will look like this. So this is an orthomosaic generated from a sensor called the MicaSense Red Edge. So this is a corn maze, and it shows it really well. You can kind of see there's a second corn maze in the corn maze that's all blue. And so you see blue, yellow. If you look at the roads on the right side of the image, you'll also see some blue and yellow as well. So this offset really can impact your results. So if your sensors and data don't have this issue, then you don't have to worry about doing any pre-processing. So next, to just kind of give you an idea of what some of these sensors look like, this is just a list of a few of them. This is by no means an inclusive list of all the multi-lens sensors, and I'm not trying to say they take bad data or anything like that. This is just a few examples so that you kind of understand what sensors this might affect. So since this is a customer-driven solution, it's primarily for the MicaSense Red Edge sensor, which is the one in the top left. If there's a lot of people that end up using other sensors that need to have this band alignment problem fixed, we're more than happy to help with that, but it needs to be it's a customer-driven need. So to kind of give you a little better example of how this looks with your images. So here on the left, there's an image without any band alignment. This is the same MicaSense Red Edge data. And on the right, you can see with band alignment. So this kind of works by using ENVI's recently patented tie point generation algorithms. They're really world-class algorithms, and they do a great job at finding the correct tie points between your images. And to kind of illustrate things a little bit more, here's a band animation for how the band alignment looks. Oops. Sorry, I skipped through that. And so if you look down in the bottom right-hand corner, there's a leaf that should be bouncing around a little bit. I don't know how well you'll be able to see it over the webinar. This is courtesy of Highland Precision Agriculture. And this just shows you that this is an image taken within a greenhouse. And so they're maybe a meter or two above where the plants are in a greenhouse. And between the top of the table where the plants are sitting and the ground, this lens misalignment is enough to cause the floor to move around, even though the plane that the plants are on is registered. So kind of more importantly than what this looks like is how this is really going to affect your results. So apart from something that just visually looks better, it's important to have a reason. Waiting for the webinar to catch up here. So to kind of give you a look, we did a comparison between the green atmospherically resistant index, or GARI, that's what I like to call it. So with the same image I showed earlier, and here we have a spatial subset. So this image on the left has Gary, and the image on the right has Gary within that red box. So just as grayscale images, you can't see much of a difference between the two. And so it kind of helps a little bit more to look at some graphs and some histograms of the entire data range. So this first plot on the top is for Gary with band alignment. You see the pixel range is from about -0.4 to 0.7. So that first red plot in the middle there has the entire data range. So that's a pixel value in thousands, not just, so it's about a factor of 1,000 greater. So the pixel range goes from about -10,000 to +10,000. There's a lot of outliers, and so to kind of take a closer look so you can get a view of what the histogram is like, if you limit the data range from -2 to 2, then you'll see that the histograms look significantly different from one another for that image on the bottom with respect to the image on the top. So this is kind of why you need to make sure you pre-process your data if you have a band alignment issue. So although kind of the primary thing for the UAV Toolkit is for band alignment, there's also some other things that it does as well. So I had mentioned that when I was setting up my project that if you don't have metadata information in your images, then you'll need to at least have a GPS file and a CAM file with your focal length and pixel size. And so this is just kind of a screenshot of what a GPS file can look like. So you have the image name, you have longitude, latitude, altitude, and then the sensor orientation, or the roll, pitch, and yaw. And so that's just kind of an idea of what it looks like. These are generated with the UAV Toolkit. Another thing that the UAV Toolkit does is, so even though ENVI can ingest that OneButton output directly, if you want to embed information such as the wavelengths, band names, wavelength units, then you can do that as well. And so that's kind of that first bullet point there. So we can convert the output from OneButton into ENVI formatted files. Another cool thing that it does is if you are over the continental United States, it will download NAPE as a base map. So if you need to do some base map registration, you can very easily do that. The last thing I'm going to talk about for it is that if you do have images that, if you have reflectance panel images, the UAV Toolkit can convert your data to reflectance. So using IDL, we can actually find the reflectance panels within the images. You can get the mean pixel value and then scale all of your actual data from 0 to 10,000 if you have reflectance panels. Additionally, with the UAV Toolkit, you can kind of account for the dynamic range of some sensors. And basically what that dynamic range is if you have a camera that has a different exposure time or ISO setting, ISO speed for each image, then we can kind of correct for that in a little bit. So the last thing, not last thing yet, so kind of want to take a peek at how this is going to impact your mosaics. So this is the same orthomosaic that I showed at the beginning of this slide deck. So without any pre-processing, you can see the corn maze, you have things multiple times, you can kind of see the blue outline of all the corn maze. And so if we perform band alignment, we can see the difference in our results. So you see that no longer do you have these multiple images. Instead, you just kind of see areas of there's purple, there's green, there's blue, and that's kind of the dynamic range. So the last piece here is with accounting for exposure compensation. So we'll wait for this to load up. So you can see that your areas that are blue and purple and green pretty much go away. You'll see a few edges kind of in the image, like a few edges between the images on where trying to account for that dynamic range doesn't do the perfect job, but it gets it very close, and it's actually analysis ready without doing any color balancing or anything else to reduce your pixel integrity. So since this is an IDL based solution, it's also very easy to use, and I do just want to point that out. So If you're not familiar with IDL, you can use this. You don't have to worry about getting technical with programming. It's just a couple of lines of IDL code. So this works as a two-step process. First is we're going to generate reference type points. And so using ENVI's type point generation algorithms, we can get our type points and we can save them. And part of the reason that I do this is because it saves you a lot of time. You just have to generate your reference type points and then use them for every group and restore them, then you'll save about 100 seconds or so per image group. And so this way, it takes about 1 to 2 seconds per image group. Overall, it's, because groups are ran in parallel, it takes about 0.75 seconds or so. So yeah, but since these do wrap all of ENVI's tasks for generating type points, there's a lot of different parameters that I have available in order to control them better. And so this is something that, there's a lot of parameters and options here, and so it can be kind of confusing. So it's nothing to worry about because there's documentation. So all of the different parameters for each task or procedure are outlined. And so this is kind of all I'm going to talk about. We're actually going to go through kind of a workflow with the UAV Toolkit and show the steps along the way. So I'm going to go ahead and pull up IDL. So this is my IDL script to generate my reference type points. I'm going to create an ENVI formatted file of my red edge data so that I can see the band alignment with it. And then I'm going to apply all those type points to all of my data. And so real quick, I'm just going to pull up my directory structure here to show what that looks like. So this data set is also provided by Highland Precision Agriculture, and there's some cool things I'll show about it in just a second. So I've got this folder called 000. I have another one called rigorous, and another one with results. So 000 is all of my images. Rigorous is where I put one image group. And so the images in here, let's open one up. So these kind of are images that have a lot of contrast. So when you're generating your reference type points, you want to have texture, you want to have variation in your images so that type points can actually be found within the images. And so that's kind of what I chose here. This data set is a strawberry field. So you see you have some nice linear features, but there's also some variation within those features to delineate them from one another. So I'm going to go ahead and I'm going to hit run. So as this code works, all you have to do, it's not a separate installer or anything. You just have to have UAV_toolkit, and then once that save file is on IDL's search path, then when you type that, it will restore it automatically, and so you don't have to do any installation. So we'll go ahead and we'll open up this first procedure, red edge to ENVI raster. So there's a folder here now called ENVI format. So I'm just going to click and drag that into ENVI, and we'll take a look at it. So you'll see it kind of similar to the corn maze. Looks a little goofy almost, like you should be wearing 3D glasses when you look at it. So if you just look at the rows, which these are the rows of the strawberry plants, you'll see there's red, there's green. If you zoom in a little bit, it looks pretty goofy. And so it's pretty apparent that you need to account for the band alignment in this data set as well. And so while this is running, so there's actually some output that gets generated in the IDL console. So it will tell you some basic information about your image, the sensor latitude, the sensor longitude, the sensor altitude. If the roll pitch yaw information is in there as well, it will grab that while it's processing. So it runs pretty quick. It's actually dependent on the altitude that your images were taken at. The reason for this is because if you have lens offsets, the higher off the ground you are, the farther apart your images will lie. This means that the search windows for finding type points is going to be bigger for those images, and the larger the search area, the longer the algorithms take to find the actual type points. So some other information that this spits out, it tells you the number of tie points found between your reference image and the image that you're going to warp to it, and tells you the number of pixels between those tie points. So here we see we have like 9.3, 16.6, and 4.1. So some of those offsets, they're not too bad. They're actually pretty good, but it's still enough to visually see a difference. So this took 129 seconds, so it was pretty quick to generate our reference tie points. So we can go back, and now there's going to be a folder called rigorous_out. And if I open this up, there's going to be a .dat file, which is an ENVI formatted file, and a .tiff file. And this is going to be a multi-page TIFF for ingesting into ENVI OneButton. So we'll go ahead and we'll open up the results now. And give me just 1 second. I'm going to make 2 views here. And I'm going to link them together. Oops. Okay. So if I make this full screen, you can see it's similar to the corn maze. Image on the left looks really goofy. It's like you should be wearing 3D glasses. Image on the right, it's actually lined up. All of the pixels look great. This is something that you can actually process with OneButton. So really cool thing I want to point out too, so like the work that Highland Precision Agriculture is doing, they're taking really high quality data, really high spatial resolution. So these are strawberry plants. And that's really cool because if you zoom in, you can actually see the little red pixels, which I'm guessing are the strawberries in the plants themselves. So I thought that was pretty neat. I just wanted to point that out. So I'm going to go ahead and I'm going to zoom out. And then I'm going to go ahead and I'm going to hit resume in IDL. So I'm going to then apply my tie points that I've generated to all of my images. So one thing I do want to point out, so I have this keyword here called grayscale. And so if you do have reflectance panels, so in this case the reflectance panels are grayscale reflectance panels. So they don't reflect at 100%, they reflect at 70%. So if you have this information, then what you can do is you get the mean pixel value from your panels, and then those get scaled up as if they were 100% reflectance. And so as this is going, there's some information that gets output into the IDL console. It will tell you the mean pixels, the number of pixels in your reflectance panel, standard deviations. And so the kind of the process it goes through is it finds your reflectance panels if they're there. It will account for the dynamic range, which I just called the co-calibration scales. And then after that, it will apply your reference tie points to all of your images. And so that's what's going on here. So it runs pretty quick. Overall, I think this takes like 70 seconds to run. And so it's really fast, and there's 74 image groups. And so it's less than 1 second per group in all. So that's all that I had for the UAV toolkit. I think we can go ahead and open it up for questions.
Thank you, Zach. A lot of questions that have come in. So let's see, first one, can this tool work with UAS imagery from a military drone like a Predator? The files are .ntf.
So as long as ENVI could read them, then it should be something that could be worked out. So like this UAV toolkit, since this is a customer driven, so it's really only for the MicaSense Red Edge sensor, but that framework is there to easily expand this to other sensors. It really just depends if there's other people that want to have support for that sensor as well, and then it could be added in there. But minimally, it needs to be read into, needs to be able to be read into ENVI to be processed.
All right. Can ENVI OneButton Mosaic ortho-rectified hyperspectral data?
So as long as it depends if it's a frame-based sensor or not. So that's the only requirement, is that it's actually frame-based. Like Asaf had mentioned, at the last little question break is if it's a line scanning, then it will not work.
Very good. What is the maximum number of images a one-button project can handle?
So OneButton is not limited to any number of images. The most that I ran through, I had was about 1,250, and it took about an hour to process. So there's no limit on images. There's no limit on the image size, whereas, you know, it doesn't seem to slow down too much with that either.
We had another question where someone was telling me that they used another software tool and it took 2.5 days to process. So I think you're kind of speaking to that as well.
Yeah, and I think Asaf was trying to say something there too.
Sorry, I just wanted to add, yeah, like you said, we don't have any limit on the number of images. We've done projects with tens of thousands of images, and processing time is very quick, again, compared to other products.
Next question is, can you talk a little bit more about the differences between ENVI OneButton and ENVI OneButton Professional?
Sure. So kind of the main difference is that ENVI OneButton Professional allows you to have a lot more precise control over the algorithms for how the images are orthomosaicked. And additionally, you kind of have some post-processing control. So in ENVI OneButton Professional, you can go through, you can edit your tie points if you need to, you can edit your seam lines. So you can really control all the different parameters that OneButton basically defaults to make sure that you get the, you know, even higher accuracy and a better orthomosaic.
Great. Next question, can I download ENVI OneButton now?
Yes, you can. I think that all you need to do is make sure you have an account on our website. And let me pull up the browser here. So if I go to www.harrisgeospatial.com, then there should be a landing page which will say get your free trial of ENVI OneButton today. If I click on that, we'll let this load, then it'll take me to our promotion page. And if I scroll down a little bit, there's this blue button for get your free trial today. And then also there's watch an ENVI OneButton demonstration at the bottom. So it's just a shorter video that goes through setting up the same project we did today and taking a look at the results.
Thank you, Zach. Next question, what is the maximum number of spectral bands supported by OneButton?
So ENVI OneButton supports as many bands as you have. The only requirement is that they be in multi-page TIFF format. And so if your images aren't multi-page TIFFs, you can actually use IDL to easily convert them to that.
All right, next. Asaf, did you want to add anything?
No.
Okay. The next question, you use type generation on slopes?
As long as the images have, you know, about the same orientation, the hard point is that if you generate your tie points from images that are on steep slopes, then if you try to apply those to images that are flat, then your images aren't going to line up with one another. And so kind of the main assumption when you're generating these reference tie points, which is how you should follow with your UAV data collection, is that you're at approximately the same height above the ground throughout your entire flight. So if you're at the same height above the ground, then your images should have about the same offsets from one another. But if you're flying over, you know, really steep terrain, you're not just looking straight down, then you're probably going to have some other effects in there.
The next question, can you create text messages with OneButton?
You cut out there a little bit, Kevin.
Let me try again. Can you generate textured meshes in OneButton?
We'll let Asaf answer that one.
we're going to have this product in our June release.
Great. Another question, how can I get ground control points?
So that's something that comes about with your, I mean, either you could always use Google Maps after you've collected your data, but really probably the best bet would be when you fly your UAV data, you go out there, you put some markers on the ground, and you get really high accuracy GPS reading for where those markers are. But then when you're actually flying and you're taking pictures of those, you can go through with ENVI OneButton and you can tag those pixels in the images that have the marker to say that this is for sure at, you know, latitude X, longitude Y, sort of thing.
Thank you. The next question is, can you get vegetation height from the outputs?
So yeah, if you get, so this is where kind of your data collection is kind of important with OneButton, just because of how their algorithms are fundamentally different from software such as Pix4D. If you want a high accuracy point cloud that you can do this with, then you need to make sure that you capture your images as stereo pairs. There's some more information about this in the OneButton user manual. But once you do that, you can, if you have ENVI LiDAR, you can calculate, you can generate a DSM and a DEM, and then you can get the difference between those two to actually find the height of your plants or height of your buildings.
And then another question, can OneButton adjust for the additional effects using a DEM?
Additional effects? Was there?
Yeah, sorry, there's probably a part one to this question. Even if it's on non-even terrain, and I'm looking, I think there's even more to it, but did I give you enough to work from?
I'm still not sure. Asaf, do you understand the question?
No, I didn't. You were kind of choppy there. I didn't get the full question.
Can OneButton adjust for additional effects using a DEM, for example, if it's on non-even terrain?
Oh. So I think I understand that now. So the mosaic produced by OneButton is an orthomosaic. So your images will be ortho-rectified, and that uses the DEM that's produced during the image stitching process.
Thank you. Can you explain more about the thermal and RGB data that was mentioned?
So if you, I think that was Asaf mentioning that you can, if you don't have multi-page TIFFs with your data, the most channels that are allowed is 4. Is that right, Asaf?
So come again. Come again.
So when you're ingesting your images into ENVI OneButton, you can have N channel images and multi-page TIFFs. And so if you have N channel images, you can have RGB in another band, say NIR or thermal or something like that. And the most
yes,
for,
so,
go ahead.
Yes, sorry. For multi-page, we support any number of pages or channels or bands. For multi-channel, which is I think you refer to as stacked, we support up to 4. But thermal, yeah, like you said, can be one of those 4 bands or one of those N, multi-page bands.
Thank you, Asaf. This one might be for you as well. Does OneButton include a correction for the rolling shutter effect that many sensors have?
No, our algorithm corrects it in our bundle adjustment. We do not have a specific model for it, but we found that with a lot of the sensors we processed, we did not see the rolling shutter effect in our outputs.
Great, and Zach, I think this one's for you. Can OneButton process airborne LiDAR data like LAS formats?
So OneButton is not meant to process LAS. If you already have, so if you have a LAS sensor on UAV data or a UAV, then I'm guessing that you probably should have software that comes with it to produce a LAS file from that output. With your LAS files and ENVI LiDAR, you can actually process your point clouds to get trees, you can get buildings, you can get power lines, you can also generate your ortho products from a point cloud as well, like your digital surface model or your digital elevation model.
Zach, I'd just like to add that with OneButton Professional, if you have a point cloud or a DTM from another source, you can use that as a basis for your ortho rectification in OneButton Professional.
Great. Zach, you're actually on the website right now. So someone asked, how do you download the trial? I think maybe they're looking for a download button as opposed to what happens when you click on the free trial. Can you elaborate on that?
So you should, you have to create an account. And so once you have an account, you will go to your login. Give me just 1 second. I'm not going to sign in so everybody can see. So there's going to be a downloads page on your account. Give me just 1 second. So once you can click on this My Account tab up here in the top right corner, and there will be a Downloads. And so if I click on Downloads, you should see here we'll have OneButton and you'll have OneButton Professional. And so if you want to try out OneButton, the promotion is only for OneButton and not OneButton Professional. So I hope that answers the question.
Yeah, and I think just to kind of follow up on that, if you were to click on our website on the get your free trial, it would send an email to the sales team at Harris Geospatial. Is that correct? And they could follow up with you?
I think so. I'm not 100% sure where that email goes, though.
I'm sure, though, if someone sent it, though, they'd be followed up with.
Yes.
Great. Someone mentioned that they weren't able to see the webinar from the beginning and was wondering if it will be recorded. So if you could just reiterate that as well.
Yeah, so like I mentioned at the beginning, this webinar will be recorded and put on our website. Additionally, if you are interested in seeing the PowerPoints that I have, you can send me an email and I will send that to you. Let me pull up my contact information again real quick. So yeah, here's my email address. If you're interested in getting the PowerPoints, I'd be more than happy to send them to you.
Thank you, Zach. We have several other questions coming in, but want to try to stick to our schedule. We know we're already running a few minutes late. So I'd like to thank Zach Norman very much for giving this very informative presentation. Asaf, thank you also for helping answer some of those questions. And we look forward to seeing you guys again, hopefully on the second part of the webinar or the related webinar that will be coming up in a few weeks. Thank you, Zach.
Yeah, thanks everyone for joining us.
Thank you, everyone.